Hello class, and welcome to today's algebra lesson, which is about arithmetic sequences. By the end of today's lesson, you will be able to identify these sequences, find the next three terms in the sequences, and write and solve equations for the nth term of the sequence. So we're going to start with what is a sequence. A sequence is a list of numbers in a specific order. So it could be, for example, the counting numbers, 1, 2, 3, 4, 5. That's going in a specific order. We're going up by 1 every time. This next set is also a sequence. So we start with 1. We add 0 to get to 1. We add 1 to get to 2. We add 1 to get to 3. Then we add 2. Then we add 3. Then we would add 5. Then we would add 8. This particular sequence is called the Fibonacci sequence. It is not an example of an arithmetic sequence. An arithmetic sequence is a sequence whose successive terms have a constant difference. So what that means is we get from one number to the next number by adding. When it's talking about terms, it's talking about the numbers in order. So in this example, 3 is the first term, 5 is the second term, 7 is the third term. We get to each term in this sequence by adding 2. In the next example over here, we get to every number by subtracting 4. Those values that you are adding or subtracting by is called the common difference. So we would write that out for this 3, 5, 7, 9, 11 sequence. We would say D, which stands for the difference, is equal to 2. For the negative 21, negative 25, negative 29, negative 33, we would say D is equal to negative 4 because we are subtracting by 4 in between every term. So our first job is to identify whether a sequence is arithmetic or not. Again, we're going to do this by looking for a common difference. So we're going to look at our sequence, and I've got negative 8 to negative 5. That is a difference of plus 3. Negative 5 to negative 2, once again, difference of plus 3. Negative 2 to positive 1, once again plus 3, and 1 to 4 is plus 3. So this is an arithmetic sequence, and your reason would be common difference is equal to 3. So we give the value that we are increasing by. If I look over at my next sequence, I've got 1 to 4 is plus 3, 4 to 9 is plus 5, 9 to 16 is plus 7. So we can already tell this is not arithmetic. You actually could have discovered that after the first two, and that is because there is no common difference. So if it is not an arithmetic sequence, we need to write out the fact that there is no common difference. That is what makes it non-arithmetic. Go ahead and try this one on your own. In this case, your sequence is arithmetic, and you are subtracting by a common difference of 7 every time. So once we have a sequence, the next thing we can do is add onto it. So going back to that example from the first one I did, where I had negative 8, negative 5, negative 2, positive 1, positive 4, my common difference was adding 3. So my next term then, after 4, would be 4 plus 3, which would give me 7. Then I would do 7 plus 3, which would give me 10. And then I do 10 plus 3, which would give me 13. So my next three terms would be 7, 10, and 13. Go ahead and find the next three terms for this sequence on your own. Subtracting our 7, we get negative 10, negative 17, and negative 24. Sometimes we want to be able to move beyond just the next 3 or 4 or 5 terms, and we want to find something much further along in the sequence. In order to do that, we can use the equation seen here. Within this equation, this AN stands for any number, so any number within the sequence. The first term is represented by A1. So this is the first number listed in your sequence. The D stands for that common difference that we were talking about, so how we get from number to number. And then we have n minus 1 in parentheses as part of our expression. So if I'm looking at the sequence that I've been looking at, -8, -5, -2, 1, and 4, my common difference is still 3, and my A1 term is -8. So when I start writing this expression, I would say AN, notice that N is in the subscript, and that's going to equal my A1 term, which is -8, plus 3, because my common difference was +3, and then in parentheses, n minus 1. So that's how I start my equation. I now need to simplify it. The first thing I'm going to get rid of is those parentheses. So I've got AN is equal to -8 plus 3 times n, which is 3n, and then 3 times -1, which is -3. So I've gotten rid of my parentheses, and now I need to combine my like terms. -8 can go with -3, so I end up with AN is equal to the 3 n's, and then -8 minus 3 gives me -11. So my equation that I'm going to use for this sequence is AN is equal to 3n minus 11. That's the writing the equation part. The other piece that it asks us for is to find the 72nd term. So when I do that, I'm going to say A72 is equal to 3 times 72 minus 11. So what I would write as my answer then is I would say A72, so saying the 72nd number in the order is equal to 3 times 72, which is going to give you 216, minus 11, which is 205. So we would write in A72 is equal to 205. It is important that you write in A72 because we need to know what number it is in the order. We can't just write 205 because we don't know where it would fall in the order then. We would write A72 equals 205 to show that that's the 72nd number in the order. Go ahead and write the equation for this sequence on your own. So we plug in our A1 and our common difference. We distribute and simplify to get AN is equal to -7n plus 26. Now go ahead and find the 45th term on your own. So we plug in 45 and we get that A45 is equal to -289. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.